back. This is A-level computer science 9618 paper 3 chapter 6 part 2, and this is AI. The name of the chapter is AI. So in the previous video we discussed about the Dijkstra's algorithm and A-star algorithm. Okay, one thing I made a mistake in here, that it was the heuristic value was 13 instead of 14. Okay, so 1 2 3 4 5 6 7 8 and then 9 10 11 12 13. Since the heuristic value was 13, so if it was 13, it would be like this is 13, then 12 11 and 12 11 10, so like that. Okay, then 9 8 7 6 5 4 3 2 and 1. That was a mistake. And another mistake was I've done here is 5 plus 7 is actually 12, not 13. But don't worry, it still didn't change anything. You always see the least total number, so that was the least number. 11 was less than 12, so 11, we choose 11. That was a mistake. Otherwise everything is fine. So let's move on ahead and understand about what is AI, what is artificial intelligence. So coming to AI, we need to understand there are three types of AI: narrow AI, general AI, strong AI. Then we're going to understand about machine learning and the types of the types of learning that we do in machine learning, like supervised learning, unsupervised, reinforcement learning, semi-supervised learning. These are four types of machine learning. And then we're going to understand about deep learning. That deep learning is how it helps the machine to think like a human being. Okay, so let's start from here. AI. What is AI? The device learning from its environment and the data it receives. So it is learning and it receives data, become increasingly sophisticated, which means it is keep on learning, getting better and better in its response. So if you are making a robot and you are giving the data, okay, to that robot, and after giving data, the data is learning on its own. It's keep on making its improvement. When you are asking something, then it gives a better response each time you try to give the data. Okay, showing the ability to use automated repetitive learning through artificial neural networks. Artificial neural networks, this one is talking about deep learning, and we will discuss this later, don't worry about it. So AI is basically a device that a model, you can say, that keeps on learning, and you just keep on giving the data, or it is getting data, it's keep on learning, it's improving its response, and how it is, and the ability to learn is through deep learning. Okay, there are three types of AI. Narrow AI is machine has superior performance when doing one specific task. That's narrow AI, too narrow. Strong AI is machine has superior performance. Okay, same thing, but doing many tasks. Okay, machine has a superior performance to a human being in many tasks. Machine has superior performing to a human being when doing one specific task. Many tasks, one specific task. That's narrow, that's strong. General is machine is similar in its performance to a human being in any intellectual task. That's a difference. These are three types of AI. Now let's understand more deeply that what actually is AI. AI, a machine, a model, you can say, or it's an intelligent machine that think and behave like a human being. So it's learning like a human being. Okay, it's learning by getting more data and keep on improving its response when giving the response, when giving the output. And also it thinks like in order to get response and in order to learn, it use deep learning. Deep learning means thinking. Deep learning is connected to thinking. It thinks like a human being and then behave like a human being. Okay, another thing to tell, that AI, let's just say this is AI. Inside AI is machine learning, and inside machine learning is deep learning. Okay, deep learning. So deep learning is a subset of machine learning. Machine learning is a subset of AI. So deep learning and machine learning, they work together all the time. That's why you need to understand that machine learning and deep learning are not different things. They are at some point work together. Okay, they are not independent to one another. They are dependent. Okay, so So what makes them intelligent? Through machine learning. They have to learn, right? We need to make them, we need to teach them either, I mean, the way to learn, on itself, without telling them to learn. Okay, we're not telling them to learn, they are learning themselves. Since systems learn without being programmed to learn. What are the applications? There are so many applications, like for example in healthcare and diagnosis. Having in the future, in the upcoming future, we could have robots working as a nurse or a doctor, giving healthcare tips or like that. Better marketing techniques. For example, we having AI in our banks uh, giving suggestion whether we should give a loan or not, or it also helps in cyber security. When there are so many attacks in a bank, there are so many attacks, so AI try to see the pattern and they try to help to defend it. Okay, so it's used in marketing strategies, better marketing techniques based on buying behavior of the target group. Increase efficiency in healthcare and diagnostic, and also help in cybersecurity. There are so many applications. Okay, it's not really. There are so many applications, and it's very awesome thing. Even though I haven't learned anything about AI yet, I will learn it. But for now, let's start from here, the basics, that what actually is AI. We will learn this together. Okay, so machine learning recognize object as labeled. Okay, there are two things to understand: labeled data and unlabeled data. What is the difference between labeled data versus unlabeled data? Label means that you are labeling it. You are for example, if I make this, I'll say this is a square, this is a triangle, this is a rectangle. I'm labeling it, but there are some picture which are unlabeled. Okay, I'm not labeling them that what it actually is. And for now, you need to understand what is labeled and unlabeled data. Okay, I'm labeling it that this is a square, this is a triangle, and unlabeled data is not something that is not labeled. Any object which is not labeled. Okay, knowing the target answer and data object is fully recognized. Telling the machine that what is this, what is that. I have a machine in front of me, and I'm showing the machine that, hey, this is a triangle, this is a rectangle, this is a square, this is a human being, this is a dog, and you are actually teaching the machine. You are giving labeled data to be trained. Okay, unlabeled data is something that is not labeled. You're not telling the machine what it actually is. That's the difference between labeled and unlabeled data. Okay, we use labeled data to train, to allow the machine to be trained. Okay, labeled data, what kind of vehicle, whether they labeled data, this is the example, what kind of vehicle, whether they have been surveyed, whether they are, okay, this is quite complex, but I have just given you a simple example that it just shows the machine that this is a square, this is a rectangle, this is a triangle, this is a donut, this is the pepperoni, this is the biryani, something like that. Okay, labeling, you're telling the machine. Okay, this is label. This unlabeled data is unidentified and need to be manually recognized by the machine itself. We use label and unlabeled data to train the machine. Okay, and there's so many ways to learn it. There's so many ways to train it. Okay, the spam detection search engines. Okay, these are just examples of machine learning. Spam detection comes in supervised learning. Let's just start from here. Types of machine learning. There are 4 types: supervised learning, unsupervised learning, reinforcement learning, semi-supervised active learning. What is supervised learning? Supervise, you can just see the word supervise, supervision, having a teacher to teach you. Like I'm teaching you guys right now. I'm a teacher, you guys are students. I'm telling you what is this, what is that. I'm giving you labeled things, label information. I'm using the labeled data to teach you guys, and then after giving you guys the knowledge, then you can decide it for yourself. Okay, it's the same thing that your parents are teaching you something, that this is right, this is wrong, and then when you are being programmed, then after that you can just make a decision for yourself. Okay, you're having your own life, you are making decision for your own self after learning it from your parents, from your teachers, from your seniors. Okay, so process of learning with training labels. We are training you, okay, using labeled data, labeled it. Regression analysis we discuss this later, class view analysis discuss later. Predict, okay, so we are using labeled data to train you guys and predict future outcome based on past data. After teaching you all the stuff, then you can predict the future, you can make your own decisions. That's supervised learning. That's exactly what the machine is doing. We are teaching the machine the label data, we are giving the machine the label data. The machine is keep on learning and keep on learning, and then the machine is capable of making decision for themselves. I mean, predicting the future outcome based on past data. Okay, it requires both an input and an output so that it can be trained, which means machine is, we are giving the machine the label data. We are labeling it, we are telling it what is right, what is a donut, that this is a donut, this is a triangle, this is a square, label data. And after giving the input, and if the machine gives the output, and the machine learns from the output itself. It keeps on learning, and yeah, output also very important for the machine to, the machine also check the output. Okay, output, okay. For example, if I'm teaching the machine so many things, and after giving so many input data, after giving so many label data as an input, then I put a donut in front of a machine, and I'm asking the machine, what is this? If the machine said that this is a donut, then yes, hooray, successful. But if it says that this is a tire of a vehicle, then we can say that there is an error. There is an error in recognizing it. So this output, we actually try to measure the difference between the real output and the predicted output. The real output and predicted output. We try to see the difference between these two, and once we got the error, the range of error, then the machine try to see this error. Okay, so I've made this error, and then it tries to improve itself. So that's why it says needs an output to improve itself, keep on learning, keep on improving its response. Okay, using label data, once straight the model is run using label data, results are compared. That's what I'm telling that after giving the output, after giving the results are compared with the expected output. If there are any errors, the model needs further refinement, which is back propagation, which means it goes back, it tries to fix itself, and then it tries to improve itself. We will discuss this later. But I'm just giving you an overview. What is this? Model is run with unlabeled data to predict the outcome. Unlabeled data, which means you are putting something and you are checking that the model should give you the expected output. For example, I am putting a tie in front of the model, and I want to see what the output it gives. Okay. So first we try to use label data. We try to use label data to train the model, and then we try to test it using unlabeled data to predict the outcome. Okay, now let's discuss about what is regression analysis, what is classification analysis, and what is propagation, what is back propagation. Okay, regression analysis is a way, this regression, there you go, a way of analyzing data before it is input into a system or model. Is one way of analyzing the data, used to make prediction from given data by learning some relationship between the input and the output. So it's all about learning the relationship between the input and the output. Okay, that's what regression analysis is. Helps in understanding that how the value of a dependent variable changes when the value of a independent variable also change. It tries to see the relationship between input and output, between dependent variable and independent variables. Okay, so that's regression analysis is. What is classification analysis? Model tries to predict the correct label of a given input data. It tries to classify it. Okay, yeah, it tries to classify it. Like there are so many there are different types of it. There could be a different types of square. Like this is a square, this is also a square. Okay, these two are quite different, but they have these four pointy sides. So the AI will just try to see the sides, and then it will say that yes, this is a square, this is a square. So you are classifying them as a square, okay, even though they are quite different. Models try to predict the correct label of a given input data. Okay, and yeah, back propagation. If, for example, the AI have done some predicted error, not the result is not right. I mean, comparing with the expected output, there is an error. The model needs further refinement, which means it's going to keep on updating itself. So back propagation is, I've written here. Where have I written here? Back propagation. Here we go. Back propagation is when designing neural networks. Okay, it's all about neural networks. For now, you just need to understand that it keeps on improving itself. For now, we will come to deep learning for later. Right now, you need to understand that it keeps on improving itself. Okay, once it gets the error, it tries to resolve that error. That next time there shouldn't be any kind of error. It tries to repeat it. It tries to improve itself from these feedback. You can say feedbacks is very important for the machine, for the AI, for the model. Okay, so this is supervised learning, where you have a supervisor, you have a teacher to learn the student. You can say the AI, the model, keep on learning it, keep on telling it that this is right, this is wrong, this is square, this is a rectangle, giving labeled data. And after completely learning this, the AI can make a prediction for themselves using past data. So that's supervised learning. Unsupervised learning is something that we don't tell the machine that this is right, this is wrong. The machine try to identify things for themselves. They try to do it themselves. Okay, so we try to give them unlabeled data to identify hidden patterns. They try to give us patterns from the input data provided. Okay, the world around us basically provide training labels. So we are giving the machine unlabeled data, which it is not labeled, making data more readable and more organized. Okay, it tries okay, so using unsupervised learning, it tries to identify hidden patterns, and also it also helps to data make more readable and more organized. It classifies unlabeled real data. Okay, doing clustering or grouping. Clustering means recognizing different properties like this and creating categories. Organizing categories, seeing the pattern is unsupervised learning. Modeling the world, predict the outcome using unsupervised learning. Learn or correct, update its belief to agree with its observation of the world. Also, unsupervised learning also try to update itself. Okay, so back propagation used in supervised and unsupervised learning. Back propagation, this one, it is used in supervised unsupervised learning as well. Tries to update its response. Okay, it's after getting the output, it tries to see. It's just try to keep some updating itself in unsupervised learning as well. Okay, reinforcement learning is when you are not trained, definitely not trained. You're using trial and error in algorithm to determine which action gives the highest optimal outcome. For example, you have a maze. Okay, you have a maze, and this is a box, and you're going here and you have to reach here. So you will try to see the best optimal solution, I mean the shortest path. Okay, you will find the shortest path. So let's say we have given the task to the machine to come here to here. Machine will go here and then come back, and then go here and then go here, then go here, come back, and then go here. It took so much longer time to reach here. Okay, but it tries to see that what are other best alternatives to reach to the destination in a short amount of time. Okay, so it used trial and error. Okay, determine which action gives the highest optimal outcome. It tries to improve itself to find the shortest most path. Okay, so this after improving itself, then it tries to go straight right and straight down. So yeah, and then the machine gets a reward like a positive a +1 point. Okay, you can say, yeah, gives a it keeps on giving reward and determining that yes, I have improved myself, or that I have reached to my destination in such a short amount of time. Okay, so using trial and error in algorithm to determine which action, either going this and that and then come here, or I should just go straight right and then down. Determining which action gives the highest optimal outcome. The optimal outcome is which action would help me to reach to my destination in a short amount of time. Okay. Example is kid learning to walk. Like I mean, a 2 years boy is learning how to walk. Even though we don't tell him how to walk, it just it walks, and then it goes down and then gets up and walk. It keeps on learning itself. So that is reinforcement learning. Okay, it tried to see which action gives the highest optimal outcome. We don't know what the right thing actually is until it's completely done with the task. Okay, after giving the output, then we try to compare it. Okay, we don't know what the right thing is actually until it's completely done with the task. When the AI is completely done with the task, then we try to tell that it's not the right way or it's not enough. The process of learning in an environment through feedback from its AI behavior. Okay, getting feedback. Same thing in supervised and unsupervised. Trying to see try to compare the outcome. Okay, the output. So this is reinforcement learning. Semi-supervised learning is when you are using labeled and unlabeled data as well. For example, let's say you have a farm and you have so many cows and you want to check the health of a cow. Okay, so you're going to teach the robot. You're using labeled data, few labeled data. You're going to give the robot few labeled data so that it's completely trained. After being trained, then we can just give the huge amount of unlabeled data to giving unlabeled data so that the model could just labeling it for ourselves. Okay, so make use of label and unlabeled data to train algorithm that can indirectly query the source data and produce a desired output. It makes as much use of unlabeled data as possible, since unlabeled data is less expensive. We use it when labeling example is expensive. Then we use it. So like I'm just telling you that we have a farm and we have 500 cows, and we need to see that which one of them is infected with the coronavirus or which one is healthy. We're going to give random 5 labeled cows. We're going to give the input to the robot is learned, and then we try to tell the robot, hey, I want you to see the other 495 cows and tell me which one are. Okay, so that was semi-supervised learning. Okay, so you are using both label and unlabeled data. You're using a few labeled data to program to train the model, and then using huge amount of unlabeled data to label them and to query the source data and produce a desired output. Okay, now let's start from deep learning. What is deep learning? Deep learning is a part of machine learning, which means machine learning and deep learning works together all the time. What is deep learning? Machine thinks in a way similar to the human brain. They handle huge amount of data using artificial neural networks, which means, for example, as a human being, I have so many neurons in my brain and they are connected to one another, and that's the reason why we think intelligently. That's the reason why these neurons help us. The neurons help us to think. Okay, we have so many neurons in our brain. So similarly, AI have deep learning. In deep learning, they also have made this artificial neural network. It has become quite similar to the neurons inside our human brain. So that's what makes machine think in the same way as a human being. Okay, so they handle huge amount of data using artificial neural networks. Structure algorithm in layers: input layer, output layer, hidden layer, to create an artificial neural network, which means this is how it looks. This is the neural networks. This is the input layer where we get the input data. This is the hidden layer where there's some mathematical going on, and then we got two hidden layer, and then we got the output layer. And each of these neural networks, these neural mathematical calculations are being performed. Mathematical calculations. Everything is math in here. So mathematical calculations are being performed in these each units, these neural. Okay, so that's how it works. Everything is math, and let's just go step by step. So we have the input layer, output layer, and the hidden layer between this input and output. To create an artificial neural network excellent at identifying patterns, helps to identify patterns, learn and make intelligent decisions on its own based on the interaction between neuron in the human brain. It's similar to that. System able to think like a human using these neural networks. Okay, using these neural networks, think like a human being. Its performance improve with more data. And how does it improve itself? Using weights in each neural networks. I mean, each neural networks have weights, the weights, weights, right? Giving the weights being given to each neural network, each neural. And what is the weight? It giving the strain of each signal. The weight are numbers that fine tune how the neurons do their math to get an output. How the neurons do their math to get an output. Everything is math. Okay. So that's deep learning for you. System are able to recognize objects such as birds by their shape and color. Okay, how does it happen? For example, having a bird. This is a bird, and using deep learning, we can see the size, how it is, seeing the shape, and seeing these, seeing the pixel, the shape, how it is shaped, how the nose has been made. All these little data represented as numbers in deep learning. With machine learning, the objects form label data which can be used in the training process. So deep learning is used together with supervised and supervised reinforcement, semi-supervised learning. It is deep learning always been used with machine learning. Okay. System are able to recognize objects such as bird by the shape and color, pixel, etc. With machine learning, the objects form label data. Okay, with machine after giving the output, then that whether for example there are two birds. Okay, if these two birds have a similar nose, similar legs, we can say okay, these are similar, and then using machine learning we can label them. Okay, which can be used in the training process. It is possible for a deep learning system to take unlabeled objects and then recognize them through a sophisticated set of algorithm. Yes, mathematical calculations. Large amount of unlabeled data is input into the model. Labeled data is then entered into the model to make sure it gives the correct response. Okay, we are doing this for deep learning only. We are giving large amount of unlabeled data, we are giving input to the model, and then we try to test with labeled data using for deep learning only. Okay. If the output is not sufficiently accurate, the model is refined. Propagation, back propagation, that's where back propagation is used, because whenever you try to compare the expected output and the result, you try to see how much the error is, and then you just try to update yourself, and this way update has happened. It always happens in deep learning. You try to adjust the weights in each neural. Okay. So if the output is not sufficiently accurate, the model is refined, which means it tries to update itself by adjusting the weights of the neural until it gives satisfactory result known as back propagation. I have just totally okay. I need to discuss this. Okay. If the output is not sufficiently accurate, the model is refined until it gives satisfactory result known as back propagation. Helps to learn from mistakes that has occurred. Okay. When designing neural network, it is necessary to give random weightings. Weighting, which means, which I just told you, weightings are the weight or number that fine tune how the neuron do their math to get then output. Weights for each neurons. Okay, neural. Yeah. Okay, give random. Initially, we try to give random weightings to each of the neural connections. Okay, initially when we are creating a deep learning model. It is necessary to train the neural networks during the development stage. Okay, keep on training it, keep on asking for the output, try to make a comparison between the output, between the expected outcome and the result. Okay, after seeing the error and then telling the machine that you need to refine this, you need to fix this, and then it try to fix itself, it try to adjust the weight. Okay, the training program is iterative. If the output produced from the system are compared to the expected result and any difference in two values are calculated. These errors are propagated back into the neural network in order to update the initial network weightings. The process is repeated until the desired output are eventually obtained. We keep on updating it, okay, until the desired output is eventually obtained or gathered or get. The system weightings are adjusted to minimize the difference between actual and expected result. All neurons which are contributed to an error get their math adjusted. So it's all about math. There are two different types of back propagation. One is static, which maps static input for static output, which means weights are adjusted based on the entire training set rather than on individual example. We use the entire training set to adjust the weighting, which means this is known as static back propagation. In recurrent, we are doing repeatedly. Recurrent activation is fed forward until a fixed value is obtained. It is fed forward. Okay. Right now, I don't know much about the static and recurrent, but I think at some point you just see the definition and just, if they ask you about anything, you can just write down the definition. But because right now I don't have that much of the knowledge of AI, because I'm learning myself as well. But as much as I know so much about AI, just giving you the information. But in if God wills, I will make AI videos of coding, okay, in the upcoming future videos if God wills. But for now, I think it's all right to understand that how it is working with it. What is deep learning, by the way, and what is machine learning. If you have get the idea enough, then I think it's more than it's fine. Literally, it's just the basic. It's the beginning, because AI is much more than that basics. Okay, we have only touched what is deep learning, what is machine learning, how does it work. But in the upcoming videos, if God wills, I will make AI videos, because AI is definitely a dominant market. Okay, you can see you have seen this so many YouTube shorts that AI generating human faces. That's very inspiring for me. Literally, I want to make something like that. But hopefully, I will make it, and I'll let you guys know. Thank you so much for watching, and I think congratulations for completing this course, this complete A-level computer science P3. P3 is completely done, and I will make sure that this note is completely available on my app on Play Store. You can see Vabart's note, and you can just see the app. Okay, I will start P4 now, A-level computer science P4, and thank you so much.